There are a lot of partially correct answers below, yet none really correct, in that they all just look at specific circumstances. I understand that there are readers of this all around the world. We all have different standards and conditions that we work under. I'm in the US, the NEC is applicable here, IEC in Europe. I think the IEC is stricter and tend to engineer systems to that standard as it will always satisfy the NEC, but not vice versa. I'll get to the point real quick here. The neutral wire should always be the same size as the hot wire. That said, that isn't always true either, as there is the case of a 220/120th vac appliance, such as an electric stove oven. The cord on those will have a smaller neutral. This is because the main load is single-phase 220 vac, with 120 vac control circuits. The neutral is there for the return path for the control circuit only. Appliances have their own section of the code, and are not considered as building wiring. On a single-phase circuit, you must, according to NEC, use the same size conductor on both sides of the load. Now for three-phase power with a neutral, 3P4W type of circuit. I have only seen this used in large lighting systems. There are a multitude of ways to wire them, but it basically comes down to how the power is switched. Now if the system was designed properly, when the lights are on, there will be no current on the neutral conductor. If a light burns out, a ballast goes bad, or someone turns off part of the system, you will have an imbalanced condition that will result in current flowing through the neutral. Take this out to where only lights connected one phase are on. Now that neutral will be carrying the full load of that phase of the circuit. If using just two of the three phases, some of the current flows through the two active phases, the imbalance will go through the neutral, it will never rise to more than the current through one phase. You can check this out with an ammeter, it really does work that way. While we're discussing this, let me point everyone interested in proper care and feeding electrons to a part of the NEC that I've found almost nobody reads. The very first couple of paragraphs. I'll paraphrase here. It says, right off the bat, that following the code should result in an installation that more than likely won't burn down due to electrical problems. It goes on to say that, most likely, it will not be efficient or expandable, and that proper engineering is required to obtain efficiency and expandability. I'll give you an example. I was working at a semiconductor manufacturer, rebuilding after a fire in a couple of clean rooms. I had installed, relatively speaking, huge 3-inch conduits into the clean rooms. There were 3 of them going into each room, had like 121510 GTHHN conductors pulled in them. What you might call a loose fill. The 10-gauge wires were feeding 20-amp circuits. The facility manager was a bit pissy about the overkill. I took him over to the one clean room that hadn't burned up. The power panel was full of 1/2 and 3/4 conduits, each one filled to 90% fill. You couldn't get any more wire in them. I had him feel the conduits, they were all quite warm. I pointed out that all that heat was energy that he paid for every month, but didn't get any use of it. Worse yet, he had to spend more for air conditioning to get rid of that heat. Insult to injury. I was able to show him that the relatively small increase in the cost of the oversized wire and conduit would be recouped in less than 3 months in reduced electric usage. I reminded him that the extra cost was a one-time expenditure, but he would be paying forever for an inefficient, by the code, installation. And it was far less likely to burn down again. So, you engineers out there, stop spending so much time trying to figure out how to cut corners on the code. Instead, spend time making an efficient system. Spend a little time to run the numbers to show the bean counters how you are saving big money over time, versus the savings derived by cutting corners. In building wire, always use the same size conductors through the whole circuit.